A very good day. This is Shaila, Assistant Professor from Department of Mathematics from SNS College of Engineering. Today, in this lecture video, we are going to see a topic from transforms and partial differential equation. I have chosen a topic from the first unit, partial differential equation. Before going on to this, let us see what is partial differential equation and what are the types of partial differential equation. Partial differential equation means a rate of change of displacement, one variable with respect to the other. Mostly differential equation, we use its application in finding out the distance, or for example, if we have an ice cube and we want to know the melting point of it, we cannot find it out directly. So what we do is we take a time period with respect to time. Maybe it may be for half an hour or for 10 minutes or 5 minutes. So according to that, with respect to time, melting of ice with respect to time. So differentiation means one with respect to the other. In that, we are going to see partial differential equation. A partial differential equation is an equation that involves unknown function and partial derivatives. So, in a partial differential equation, you should have a derivative. Derivative means dou by dou x, a function with respect to a variable. And you can have functions and derivatives. So, you can have dou by dou x, I can have f of x function, I can have a constant. So, example I have given dou square u of x comma t divided by dou x square equal to dou u of x comma t divided by dou t. So, partial differential equation is one which involves more than two independent variables. More than two. We have two types of differential equation. One is partial differential equation. The other one is ordinary differential equation. Partial differential equation is nothing but which involves two or more independent variables. Here in this function, your independent variables are x and t. The various notations of a partial differential equation. When I write it as uxx means the second differentiation, or I can write it as dou square u of x comma t divided by dou x square. Okay. Suppose if I write it as uxt means it is differentiation with respect to x as well as t. So either I can write it as uxt or I can write it as dou square u of x comma t divided by dou x dou t. So if you want to know the order of PD, the order of PD is nothing but order of the highest order derivative. Next, we are going to see about linear partial differential equation and its classification. A partial differential equation is linear in the function and its derivatives. That is, it's given to be, see, examples of a linear partial differential equation is 2uxx plus uxt plus utt plus 4ux plus cos 2t. I don't have higher orders. Higher order in sense power of uxx whole square, uxt whole square. I don't have in that type. So linear means the power should be same throughout. Here non-linear, see here you have it as 2uxx plus uxt the whole square plus 3utt. So the power of the function varies. So that is said to be non-linear. When the powers are same, it is said to be linear, and the powers are different, it is said to be non-linear partial differential equation. Next is representing the solution of a partial differential equation. That is a diagrammatic representation of a PDE. When it is two independent variables. When you have two independent variables, I go with x-axis and y-axis. So the rate of change, it can be given, the various form. Suppose if it is an heat equation, increasing and decreasing, it goes in a curve form. So the curve form is given. So different curves are used for different values of one of the independent variable. Next is for a three dimensional we go with x, y, z axis. X, y and z axis can be represented in three-dimensional process. Heat equation is an exact example for a partial differential equation. That is, we take a rod, we heat it in the center, so that is 1D heat. When you heat it at the center, when you increase the temperature at the center, it bends, it forms a curve. So with this condition, with the boundary condition, you can apply it. Okay, so these are the basics of partial differential equation. Thank you.